California Building Code, Section 1135.1.1, addresses the use of heat detectors to shut down elevator power prior to sprinkler operation, stating that where heat detectors are used, they shall be installed in accordance with the requirements of NFPA 3. The ASME A17.1/CSAB44 Elevator and Escalator Safety Code, Section 3.26.2.15 specifies that when sprinkler protection is provided, power to all elevator cars in the protected area shall be automatically interrupted upon the detection of a fire condition by one or more heat detectors. The requirement for heat detectors to shut down elevator power before sprinkler operation may be present in other jurisdictions as well, but the specific code reference may differ. Firstly, New York City Building Code, Section 903.22. Secondly, the International Building Code, Section 3005.8. Thirdly, the National Fire Protection Association 101 Life Safety Code, Section 7.65.32. The reason elevator power is shut down before sprinkler operation is to prevent the spread of fire and smoke through elevator shafts. If the elevator is operating during a fire, it can act as a chimney, drawing air and smoke from the fire floor to other parts of the building. Shutting down the elevator power prevents this and helps contain the fire. Building codes generally require elevators to have a Phase 1 and Phase 2 operation for fire service. Phase 1 operation is automatic and is initiated by a smoke detector, heat detector, or sprinkler flow switch. When activated, all elevators return non-stop to the designated level, typically the ground floor, where they await use by fire personnel. Phase 2 operation is manual, allowing fire personnel to operate the elevators as needed, overriding normal elevator functions to access specific floors. This is controlled by a key switch inside the elevator car. The specific requirements for Phase 1 and Phase 2 operation are detailed in ASME A17.1/CSAB44, as well as local building and fire codes. Heat detectors are specifically used to ensure that elevators are brought to a safe stop and taken out of automatic service before sprinklers activate. This prevents the elevator from becoming a conduit for water and prevents water damage to the elevator equipment. Heat detectors are designed to respond to a specific temperature or rate of temperature rise. Common types include fixed temperature detectors that activate when a predetermined temperature is reached, rate of rise detectors that respond to a rapid increase in temperature, and combination detectors that incorporate both principles. These detectors are placed in elevator machine rooms and hoistways to quickly identify fire hazards. The selection and placement of heat detectors should be performed in accordance with NFPA 72, the National Fire Alarm and Signaling Code. The location of heat detectors is critical to ensure timely response. They should be placed near potential ignition sources and in areas where heat is likely to accumulate. For elevator systems, this includes the machine room at the top of the hoistway and within the hoistway itself, especially near electrical components. Heat detectors need to be installed in a way that minimizes false alarms, which could disrupt elevator service unnecessarily. Factors such as ambient temperature variations, ventilation patterns, and the presence of heat-generating equipment should be considered. Regular testing and maintenance are essential to ensure that heat detectors are functioning correctly. NFPA 72 provides guidelines for the inspection, testing, and maintenance of fire alarm systems, including heat detectors. This includes periodic testing of the detector's response time and sensitivity, as well as visual inspections to check for damage or obstructions. In the event of a fire, the heat detectors trigger a signal to the elevator controller to initiate the shutdown sequence. This typically involves stopping the elevator at the nearest floor, opening the doors, and removing the elevator from service. The fire alarm system also notifies the fire department and building occupants. Elevators can pose significant hazards during a fire. Open hoistways can act as chimneys, allowing smoke and fire to spread rapidly from one floor to another. Elevators can also become trapped with occupants inside, and water from sprinklers can damage elevator equipment and create electrical hazards. Shutting down elevator power prior to sprinkler activation minimizes these risks. Fire-rated construction is another critical aspect of elevator fire safety. Elevator hoistways and machine rooms should be enclosed with fire-resistant walls and doors to prevent the spread of fire and smoke. The fire resistance rating of these enclosures depends on the height and occupancy of the building, as specified in the building code. Fire-rated doors should be self-closing and equipped with fire-rated hardware to maintain the integrity of the fire barrier. Proper ventilation of elevator hoistways and machine rooms is also important to prevent the accumulation of heat and smoke. Ventilation systems should be designed to exhaust smoke to the outside of the building and to provide fresh air to the elevator equipment. These systems may include smoke dampers and other fire protection features. Emergency power systems are required to ensure that elevators can continue to operate during a power outage. These systems typically consist of generators or battery backup systems that provide power to the elevator equipment and fire alarm systems. Emergency power systems should be tested regularly to ensure that they are functioning correctly. Fire extinguishers should be readily available in elevator machine rooms and other areas where there is a risk of fire. Building occupants should be trained on how to use fire extinguishers properly. Regular fire drills should be conducted to familiarize occupants with evacuation procedures and the location of fire safety equipment. Fire safety plans should be developed for all buildings with elevators. These plans should outline procedures for evacuating occupants, shutting down elevators, and contacting the fire department. Fire safety plans should be reviewed and updated regularly to ensure that they are effective. Building codes typically require regular inspections of elevator systems to ensure that they are safe and in compliance with code requirements. These inspections are typically performed by qualified elevator inspectors who are certified by the state or local jurisdiction. Inspections should include a thorough examination of the elevator equipment, including the hoistway, machine room, and elevator car. Regular maintenance of elevator systems is essential to ensure that they are functioning properly and safely. Maintenance should be performed by qualified elevator technicians who are familiar with a specific type of elevator system. Maintenance should include regular inspections, lubrication, and adjustment of elevator components. Modern elevator systems incorporate advanced fire safety features such as destination dispatching, which directs passengers to specific elevators based on their destination floor, and smart elevators that can communicate with the fire alarm system. These features can improve the efficiency of evacuation and reduce the risk of entrapment. Continuous monitoring of elevator systems is becoming increasingly common. These systems use sensors and data analytics to detect potential problems before they lead to failures. Continuous monitoring can improve the reliability and safety of elevator systems. Ongoing research and development are leading to new innovations in elevator fire safety. These innovations include improved fire-resistant materials, advanced fire detection systems, and more sophisticated elevator control systems. Building owners, architects, and engineers should stay informed about the latest advancements in elevator fire safety to ensure that their buildings are as safe as possible. Elevator fire safety is a shared responsibility. Building owners, tenants, elevator technicians, and fire department personnel all play a role in ensuring that elevators are safe during a fire. By working together, we can create a safer environment for everyone. To summarize the key points, firstly, elevator shutdown requirements using heat detectors before sprinklers activate are mandated by codes like California Building Code, Section 1135.2.1.1, and ASME A17.1/CSA B44, Section 3.26.2.15. Secondly, these codes aim to prevent fire and smoke spread through elevator shafts. Thirdly, heat detectors trigger the elevator shutdown, stopping the car at the nearest floor and removing it from service. Fourthly, additional safety measures include fire-rated construction, ventilation systems, emergency power, and regular maintenance. Fifthly, adhering to these codes and implementing these measures ensure safer building environments. NFPA 72, the National Fire Alarm and Signaling Code, provides detailed guidelines for the installation, inspection, testing, and maintenance of fire alarm systems, including heat detectors. The code specifies requirements for the placement, spacing, and sensitivity of heat detectors to ensure that they provide adequate coverage and respond quickly to fire conditions. The selection of heat detectors should be based on the specific hazards present in the area being protected. For example, rate of rise heat detectors are suitable for areas where rapid temperature increases are expected, while fixed temperature detectors are better suited for areas where temperatures are more stable. The placement of heat detectors should be based on a careful analysis of the area being protected. Detectors should be located near potential ignition sources and in areas where heat is likely to accumulate. The spacing of heat detectors should be in accordance with NFPA A17.1 guidelines. The sensitivity of heat detectors should be adjusted to minimize false alarms while ensuring that they respond quickly to fire conditions. Regular testing and maintenance of heat detectors are essential to ensure that they are functioning correctly. NFPA A17.1 requires periodic testing of the detector's response time and sensitivity, as well as visual inspections to check for damage or obstructions. The testing and maintenance should be performed by qualified personnel who are familiar with the specific type of heat detector being used. Records of all testing and maintenance should be maintained to demonstrate compliance with NFPA A17.1 requirements. In addition to NFPA A17.1, other codes and standards may also apply to the installation and maintenance of heat detectors. These include local building codes, fire codes, and insurance requirements. It is important to consult with a qualified fire protection engineer or code official to determine the specific requirements that apply to a particular installation. Proper installation, testing, and maintenance of heat detectors are critical to ensuring the safety of building occupants and protecting property from fire damage. By following the guidelines in NFPA A17.1 and other applicable codes and standards, building owners and managers can help to prevent fires and minimize the impact of fires that do occur. Elevator recall is a critical safety feature designed to automatically return elevators to a designated landing, typically the ground floor, in the event of a fire or other emergency. This feature helps to prevent occupants from becoming trapped in elevators during an emergency and allows firefighters to use the elevators to access different floors of the building. Elevator recall is typically activated by smoke detectors, heat detectors, or sprinkler flow switches. When one of these devices is activated, the elevator control system automatically initiates the recall sequence. The recall sequence typically involves stopping the elevator at the nearest floor, opening the doors, and removing the elevator from service. The elevator may also be programmed to return to the designated landing immediately, without stopping at intermediate floors. Once the elevator has returned to the designated landing, it remains there with its doors open, awaiting use by firefighters. Firefighters can then use a special key to override the normal elevator controls and operate the elevator manually. Elevator recall is required by most building codes and is an essential safety feature for all buildings with elevators. The specific requirements for elevator recall vary depending on the building code and the type of elevator system. However, most codes require that elevators be equipped with both automatic and manual recall capabilities. Automatic recall is activated by smoke detectors, heat detectors, or sprinkler flow switches. Manual recall is activated by a key switch located in the elevator lobby. The key switch allows firefighters to manually initiate the recall sequence. Elevator recall systems should be tested regularly to ensure that they are functioning correctly. The testing should be performed by qualified personnel who are familiar with the specific type of elevator system. Records of all testing should be maintained to demonstrate compliance with building code requirements. In addition to elevator recall, other safety features are also important for elevators. These include fire-rated construction, ventilation systems, emergency power, and regular maintenance. Fire-rated construction helps to prevent the spread of fire and smoke through elevator shafts. Ventilation systems help to remove smoke from elevator hoisteries and machine rooms. Emergency power ensures that elevators can continue to operate during a power outage. Regular maintenance helps to keep elevators functioning properly and safely. By implementing these safety features, building owners and managers can help to ensure the safety of building occupants and protect property from fire damage. The California Building Code (CBC) is a comprehensive set of regulations that govern the construction, alteration, and maintenance of buildings and structures in California. The CBC is based on the International Building Code (IBC) and includes additional requirements specific to California. The CBC covers a wide range of topics, including structural design, fire safety, accessibility, energy efficiency, and plumbing. The CBC is enforced by local building departments, which are responsible for issuing building permits and inspecting construction projects to ensure compliance with the code. The CBC is updated every 3 years to reflect changes in technology, building practices, and safety standards. The latest edition of the CBC is the 2019 CBC, which became effective on January 1, 2020. The CBC is divided into several parts, each of which covers a specific topic. Part 1 contains general provisions, including definitions, administrative requirements, and permit requirements. Part 2 contains structural design requirements, including requirements for foundations, walls, roofs, and floors. Part 3 contains fire safety requirements, including requirements for fire-resistant construction, fire suppression systems, and fire alarm systems. Part 4 contains accessibility requirements, including requirements for ramps, elevators, restrooms, and other accessible features. Part 5 contains energy efficiency requirements, including requirements for insulation, windows, and mechanical systems. Part 6 contains plumbing requirements, including requirements for water supply, drainage, and venting. The CBC also includes appendices, which provide additional guidance and information on specific topics. The appendices are not part of the code itself, but they can be helpful in understanding and applying the code requirements. The CBC is an important resource for architects, engineers, contractors, and building officials. By following the requirements of the CBC, building professionals can help to ensure that buildings are safe, durable, and accessible. The American Society of Mechanical Engineers (ASME) is a professional organization that develops codes and standards for mechanical engineering equipment and systems. ASME standards are widely used in the United States and around the world. ASME standards cover a wide range of topics, including boilers, pressure vessels, piping, elevators, and nuclear power plants. ASME standards are developed by committees of experts who represent a variety of stakeholders, including manufacturers, users, regulators, and academics. ASME standards are updated regularly to reflect changes in technology, building practices, and safety standards. ASME A17.1/CSA B44 is a safety code for elevators and escalators. It is jointly developed by ASME and the Canadian Standards Association (CSA). ASME A17.1/CSA B44 covers a wide range of topics, including design, construction, installation, operation, inspection, testing, and maintenance of elevators and escalators. ASME A17.1/CSA B44 is used by building owners, elevator contractors, and building officials to ensure that elevators and escalators are safe and reliable. ASME A17.1/CSA B44 is updated every 3 years to reflect changes in technology, building practices, and safety standards. The latest edition of ASME A17.1/CSA B44 is the 2019 edition. ASME A17.1/CSA B44 is divided into several parts, each of which covers a specific topic. Part 1 contains general requirements, including definitions, administrative requirements, and permit requirements. Part 2 contains requirements for new installations of elevators and escalators. Part 3 contains requirements for existing elevators and escalators. Part 4 contains requirements for inspection, testing, and maintenance of elevators and escalators. Part 5 contains requirements for alterations and repairs of elevators and escalators. ASME A17.1/CSA B44 also includes appendices, which provide additional guidance and information on specific topics. The appendices are not part of the code itself, but they can be helpful in understanding and applying the code requirements. ASME A17.1/CSAB44 is an important resource for building owners, elevator contractors, and building officials. By following the requirements of ASME A17.1/CSAB44, building professionals can help to ensure that elevators and escalators are safe, reliable, and accessible. The National Fire Protection Association (NFPA) is a non-profit organization that develops codes and standards for fire safety. NFPA standards are widely used in the United States and around the world. NFPA standards cover a wide range of topics, including fire protection systems, fire alarm systems, fire suppression systems, and hazardous materials. NFPA standards are developed by committees of experts who represent a variety of stakeholders, including manufacturers, users, regulators, and academics. NFPA standards are updated regularly to reflect changes in technology, building practices, and safety standards. NFPA 3 is a standard for the commissioning of fire protection and life safety systems. NFPA 3 provides requirements for the planning, execution, and documentation of the commissioning process. NFPA 3 is used by building owners, contractors, and commissioning agents to ensure that fire protection and life safety systems are properly installed, tested, and functioning as intended. NFPA 3 is updated every 3 years to reflect changes in technology, building practices, and safety standards. The latest edition of NFPA 3 is the 2018 edition. NFPA 3 is divided into several chapters, each of which covers a specific topic. Chapter 1 contains general requirements, including definitions, administrative requirements, and qualification requirements. Chapter 2 contains requirements for the commissioning process, including planning, documentation, and execution. Chapter 3 contains requirements for specific fire protection and life safety systems, including fire alarm systems, fire suppression systems, and smoke control systems. Chapter 4 contains requirements for the ongoing commissioning of fire protection and life safety systems. NFPA 3 also includes annexes, which provide additional guidance and information on specific topics. The annexes are not part of the standard itself, but they can be helpful in understanding and applying the standard requirements. NFPA 3 is an important resource for building owners, contractors, and commissioning agents. By following the requirements of NFPA 3, building professionals can help to ensure that fire protection and life safety systems are properly installed, tested, and functioning as intended. Shutting down elevator power before sprinkler operation is a critical safety measure to prevent the spread of fire and smoke through elevator shafts, avoid water damage to elevator equipment, and prevent electrical hazards. Codes like California Building Code CBC, ASME A17.1, and NFPA standards mandate this safety protocol. Heat detectors strategically placed in elevator machine rooms and hoistways trigger the shutdown sequence, stopping the elevator at the nearest floor and removing it from service. Regular testing and maintenance of heat detectors, fire-rated construction of elevator hoistways, and emergency power systems are also crucial components of elevator fire safety. Building codes usually mandate Phase 1 and Phase 2 operation for elevators during fires. Phase 1 recall automatically brings all elevators non-stop to the designated level upon fire detection via smoke detectors, heat detectors, or sprinkler flow switches. Phase 2 operation, manual control by fire personnel, overrides functions for floor access using a key switch.